I've given this video the title Simplifying A cos x plus B sin x. And when I say simplifying, what we want to do is express something of that form as just a single cos or sine function. And so it's going to be something of the form r times cos x plus or minus some angle, or we could express it as r sine of x plus or minus some angle. That's a pretty neat thing if you think about it. What we're saying is we're going to take something which is a sum of, a cos function with some particular amplitude plus or minus a sine function with a different amplitude, and we're going to be able to express it as a single cos or sine curve. Now obviously if we can do it as a cos curve, we can do it as a sine curve because they're just out of phase with each other. So when it comes to doing this, we don't have any formulas that are given to us. And if we want to, we can sort of learn some rules for doing this. So for example, we can say that a cos x plus b times sine x is equal to, if we wanted to express in the form r cos x minus alpha, then that would be true where r is equal to the square root of a squared plus b squared, where cos of alpha is going to be equal to a over r, and sine of alpha is going to be equal to b over r. Now basically if we change this from a plus to a minus, that just sort of alters these a bit. If we change it from cos to sine, again that just alters these a little bit. But we don't have any of those on our formula sheet. So let me show you a way that we can do this without sort of needing to remember these rules. So let's, for example, let's express go root 3 cos x plus sine x in the form, and we'll pick this one, r cos x take alpha, just to sort of show that we do end up getting these results here when we do that. So let's actually let root 3 cos x plus sine x equal that. And now what we're going to do is use something that we do have on our formula sheet. So that's our angle sum and difference identities. So we've got an expression here for cos of a minus b, this one here. And if we use that now, cos of a minus b, for our cos of x minus alpha, we can express it as cos x times cos alpha plus sine x times sine alpha. So this side here we can express as r times cos x cos alpha plus sine x sine alpha. So there it is. Now what we're going to do at this point is we're going to choose successive values of x and kind of evaluate both sides of this. And what we want for our values of x are that they will, on the one hand, make cos x equal 0, because that'll sort of cancel this term. And then we want to choose a value of x which makes sine x equal to 0, because that will make this term equal 0. And likewise, on the left-hand side, we can make cos x equal 0 and sine x equal 0. So let's start with, we'll actually do sine x first. So let's let x equal 0. So that's the most obvious value of x to choose to make either sine or cos equal to 0. So when we let x equal 0, cos x equals 1, doesn't it? And sine x is equal to 0. So on the left-hand side, we've got root 3 times 1 plus 0. So on the left-hand side, we've got root 3, and I'll just write it in there as plus 0. And on the right-hand side, we've got r times, well, sine x is equal to 0, so this whole term becomes 0. And this term here becomes 1 times cos alpha. So we've got cos alpha plus 0 in there. So let's simplify that a little bit. That just simplifies down to root 3 equals r cos alpha. Now if we do a similar thing, but this time let's let x be equal to, well, I guess the principal value of x that will make cos be 0 would be pi on 2. There's obviously an infinite number of possibilities there, but the first and probably most obvious would be pi on 2. So anywhere we see a cos x now, that term is going to be 0, so that term and that term will be 0, and sine of pi on 2 is 1. So we'll have 0 plus 1, and on this side we'll have r times 0 plus sine alpha. So it's going to be 0 plus 1 equals r times 0 plus sine alpha. So therefore we've got 1 equals r sine alpha. Alright, so there are two sort of equations that we get there. If you like, we can number them maybe 1 and 2 just to show in our working out. So if we were to square those and add them together, then we would have, so maybe I could show this as 1 squared plus 2 squared. Then we would have root 3 squared plus 1 squared, and on the other side we'd have an r squared cos squared alpha plus an r squared sine squared alpha. So I could factorize that r squared, and therefore I would have 4 equals, and Pythagorean identity, cos squared alpha plus sine squared alpha equals 1. So r squared is equal to 4. Now we could choose r to be plus or minus the square root of 4, in other words plus or minus 2, but really all that's going to do is just change the value of alpha. So let's just take the positive value of the square root there and say r is equal to 2. So subbing that back into equation 1, we've got root 3 equals 2 cos alpha, which means cos alpha equals root 3 over 2. So that's from 1. And from equation 2, we've got 1 equals 2 sine alpha, which rearranges to sine alpha equals a half. So what is the value of alpha for which cos alpha equals root 3 on 2 and sine alpha equals a half? Well, first of all, it's going to be between 0 and pi on 2, or 0 and 90, isn't it? Because they're both positive. So it's got to be in quadrant 1. And the value for which sine is a half and cos is root 3 on 2 is pi on 6. Therefore we can say root 3 cos x plus sine x is equal to r, which was 2, times, so I'm looking back at this one here, is equal to r times cos x minus alpha. So r times cos of x minus pi on 6. Now why don't we just quickly jump on Desmos, jump on a graph and check that root 3 cos alpha plus sine alpha is indeed equal to that. So let's get, there's root 3 cos x plus sine x, and here's 2 times cos of x, take pi on 6. Let's just show that indeed, yep, there we go. So those two are in fact the same function there.